Whether you are troubleshooting or testing electrical systems, following safety steps reduces potential hazards. The Electrical Safety Authority encourages you to follow manufacturer's instructions, use personal protective equipment as required, and always use a multimeter with fused leads.
I was troubleshooting this 600-volt panel, checking voltage with my meter, but I forgot to change the meter from the resistance setting. There was an arc flash and it burned my face and neck. I've had 3 skin grafts, I got 2 infections. It's been 2 years, I still can't have sunlight on my skin. I don't go out much with my family anymore, and when I do go out, people are staring. I don't blame them. I mean, they're ugly scars, but they say it'll get better with time, but I think these scars are my life now. If I had just taken a second to check the settings.
Electrical maintenance workers who troubleshoot know they're working on live systems. Unfortunately, they don't always use fused multimeter leads or wear personal protective equipment. User errors associated with multimeters resulted in 26 reported incidents since 1998. Again, survey respondents indicated 1 in 10 electrical trades workers have had a multimeter fail violently or explode. Use the right meter for the job. Use the meter right. Double-check the settings before testing and follow manufacturer's instructions. Lead with safety. Use a multimeter with fused leads for additional protection. More than 50% of occupational electrical fatalities occur where testing equipment has not been used. The most common piece of electrical test equipment is a multimeter. Multimeters are versatile tools that measure multiple variables: voltage, current, resistance, etc. This versatility, however, increases the potential for user error. Using the incorrectly rated multimeter or using a multimeter the wrong way can result in electric shock, fire, burns, blindness, or death. Replace your multimeter with one that has the highest category and voltage rating you'll require, and do not use it without fused test leads. Only use properly approved and properly rated multimeters and fused leads. Always check your meter and fused leads to ensure they're in good operating condition. See the accompanying health and safety guideline reference on this disc for information on how to check your meter. ESA's survey respondents reported that injuries with multimeters occurred due to operator error at 49%, category rating at 21%, defective equipment at 18%, misuse at 10%. Recent studies and simulations commissioned by the Electrical Safety Authority concludes that the use of fused leads is a highly effective way to prevent possible catastrophic results if a multimeter is being used in an inappropriate way or experiences an internal failure. Fused leads reduce arc explosions created by meter failures in up to 90% of the time in simulated tests. Meters can fail when the leads are in the ammeter or ohmmeter slots, creating a short circuit across phases when used to measure voltage. Meters can fail when the selector switch is on the wrong setting when put into contact with an energy source. Meters can fail when transient spikes increase voltage beyond metered capacity. Motors, capacitors, and power conversion equipment, as well as lightning strikes and transmission lines, can generate high-energy transient spikes. Meters can fail when equipment has not been properly checked for wear and tear before testing. Fused leads in a dead short simulation demonstrate that they would avert an explosion. Meters can fail when units are subjected to higher voltages than the meter is rated for. Fused leads will not protect you if you exceed the voltage rating of the fuse. Use an approved minimum Cat 3 meter with fused leads as an additional protective measure. Select a multimeter that meets your highest voltage measurement needs. Check that meter leads are connected to the correct terminals and the meter is on the right setting. De-energize the system wherever possible. Lock out and tag out at the panel or switch. Verify that you have de-energized the correct circuit. Lockout, tagout is a key safety component. Check for power at the device using a properly rated meter. The testing procedure that should be followed requires that you 1. Test the tester on a known circuit. 2. Test live on the circuit you're working on. See if it's energized. 3. Go back and test the known circuit for verification. Proper testing is a key safety component. Ensure your fused lead voltage rating is adequate and that the fused leads are in good working condition. Fused leads can protect against the most common user errors. For example, here is what happens to a multimeter used on the wrong setting. Here you see how fused leads protect against malfunction of a multimeter used on the wrong setting. Fused leads are a key safety component. The Occupational Health and Safety Act requires the use of personal protective equipment, or PPE, when testing live electrical systems. PPE provides an additional safety component, and as you can see, it can protect workers in the event of a meter failure. The Electrical Safety Authority recommends adopting safe work practices to reinforce a high level of safety performance. The Electrical Safety Authority's 15 basic safety steps are highlighted in the Safe Work Practice Guideline on this CD. What are your safe work procedures? You are encouraged to produce safe work practices that adopt these safety steps as a minimum and incorporate the unique and specific requirements for your facility. Customers, supervisors, facility owners need to educate employees and ensure safe work procedures are followed. Non-compliance with these regulations could lead to charges being laid under the Occupational Health and Safety legislation or the Criminal Code. Choose to avoid the risk. Work safely. Work to live. Visit www.esasafe.com for more information.